Okay, now moving towards the parallel configuration. In my last video, I talked about the reliability enhancement, and that was for the series configuration. Now we are moving towards the parallel configuration. So in this we have this everything is the same. It's just the circuit or the RBD is a parallel one. So now we have enhanced our R0 plus delta R0, and we have kept the formula as the formula was something for a series system. It was like this, say R1 R2 times R3 Ri minus 1 Ri plus 1 and R of n. So it was the formula as for the R0, but after enhancing R0 plus delta R0, we keep it as Ri plus delta Ri. So that was for the series one. So if you want to study about the series configuration, I can share the link in the description, so you can take it from there. Now let's move towards the parallel one. Let's just don't waste time and move towards the parallel one. So in parallel, as you know that we have the RBD in this form. So 1 minus R1, 1 minus R2, 1 minus R3, 1 minus Ri minus 1, 1 minus Ri, and after enhancing our equation to R0 plus delta R0, so we enhance it like this, in this way. So Ri plus delta Ri, it becomes like this, and the rest is 1 minus Ri plus 1, 1 minus R of n. So it's all for the parallel configuration. So now, this topic is for reliability enhancement. If you don't know about the parallels and series RBD, so you can search it and go through the other videos. I have them too if you want, so you can see them from my channel also. You can search from there. Okay, now let's move towards this. So as in the series configuration, I have make you understood that this whole equation is being written in the form of delta R0 like this. Delta R0 equals to delta Ri times j going from 1 to n j, that is not equal to I. This I and j is not equal 1 minus R of j. Why we took this 1 minus R of j? Is that because it is because we have a parallel configuration, so everything in parallel is in the form of 1 minus R of j. So we took it like this, and so the equation, it becomes like, see, 1 minus, we have kept all these, and 1 minus Ri, 1 minus Ri plus 1 R, 1 minus R of n, plus we have this delta Ri. It was here, it's happening the same thing as we did in the series one. So delta Ri got multiplied with all of these. So this 1 minus Ri got multiplied with all of these, and the delta Ri got multiplied with all of these. It's the difference is that we have only 1 minus left here. We have 1 minus, this extra one is here. So what we are going to do with this thing, let's move so it becomes clear to you. Okay, so the equation, here we have wrote the formula that is for delta R0, and this whole thing can be written in the form of like this. It's that we have j going from 1 to n and j that is not equal to I. Okay, so now the next, let's move towards this thing. Now what we are gonna do with this 1. So what we do, we have R0 equals to 1 minus this equation, 1 minus R1, 1 minus R2, 1 minus R3, 1 minus Ri minus R of n. So we have this equation, and here we have R0. So this one is here, and we have to remove this one, and we have to bring it over here, so that we got the whole term like this, and we can keep it this thing as, we can keep it as in the form of like this. So we can easily then keep it, this whole thing, in the form of like this as we did before. So this one is irritating us. So we took it towards the right, towards the left hand side. When it's gone, see, minus, it was plus, so it becomes -1, and plus r0 remains as it is, and rest is the same. And it was 1 minus, so this minus remains here, and rest is the same. And we took the minus as common, so it becomes 1 minus r0, and this minus sign goes away, they both cancel out, and now we have this equation in the last. Okay, so as we see that 1 minus ri is the extra one. Okay, so we bring it over here, so it becomes 1 minus r0 over 1 minus ri, and this whole thing can be written like this. Why we wrote it like this? Because this delta ri comes from here, and this whole thing, the above thing, this one, and whole this thing is basically what it is. It is a product from j going from 1 to n, and j is not equal to I 1 minus r of j. So it's the product of all the j's that are going from 1 to n. As you see that r1, r2, r3 are somewhere like ri minus 1, ri plus 1, and r of n. They are all the product of j going from 1 to n. Okay, so everything is clear till now. So we have in the series we got something like this, in the series we got something, here, sorry, delta r0, we got delta ri into r0 over ri. In series we got it like this, and but in parallel it is a bit different. What is the difference? We have got the thing like this, 1 minus r0 over 1 minus ri. We have got it like this. So now how it becomes, it was like this, and this thing is equals to this. So what happened then? Okay, okay, so here it is, and delta r0 equals to, sorry, that was a quite battery break sorry for that. Delta r0 becomes this thing here times delta ri. As I told you before that this thing is equals to, this becomes like this. So it's simple, we did it before in the series also, that delta r0 over delta ri, this thing comes here, and it remains here only this, which is equals to 1 minus r0 over 1 minus ri. And what we get now for delta r0, this delta ri goes here, and delta r0 value is this. So we got a value for delta r0, that is 1 minus r0 over 1 minus ri times delta ri. So this is the value for delta r0. This is our first equation. And what it says that, last time you remember that in series we have in denominator ri. So we talked that ri is the component which has the lowest reliability, and we have to work on the ri component in the series. Now we are talking about in parallel. So just remember that what we got now, 1 minus ri. So just remember, then in parallel we have to work on the component which has the highest reliability. Okay, so it's opposite in the parallel configuration. In reliability enhancement, we have to work on the component which has the highest reliability. Okay, so it's just that we give it as, we name it as equation 1, and or is for that this equation can also be written like this, in the form of this. So we, as you know, to give the answer of our question 2, that was that how delta R0 reflects on delta Ri. So just to prove our question, to give the answer of our question, we simply write here delta Ri becomes this thing, delta R0 1 minus Ri over 1 minus R0. So this is the effect I have written also, that comes on delta Ri. So this is our answer 2. That was answer 1. What in parallel we have to work on the highest reliability component, and the question 2 is that delta Ri becomes in the form of like this. So this delta R0 reflects like this to delta Ri. So it's finished up till now. Now the next thing, okay, so it's the same in the series. We did the same things. Now we are still doing the same, it's just the parallel configuration. So obviously by doing the parallel thing, there will be a little difference in the equation and all the things. So again we are talking about no constraints. So when we have no constraints, you remember that we took delta R0 like this. We talk about delta Rj and we take it k as going from 1 to n, and we put it like j that is not equal to k and 1 minus r of k. So this is the equation when we take it as no constraints. So it's simple that this delta Rj comes here like this, delta R0 over delta Rj, and the rest is we got from the we know that when we are talking about this thing, when we are talking about delta R0, when it was like this Ri, so the equation was this. Now we are talking about delta Rj, so now the equation would be R0 del 1 minus R0, 1 minus R0 will remain the same, and in the denominator last time when we are talking about delta, I mean to say in the above one, when we were talking about delta Ri, so it was 1 minus Ri, and now we are talking about delta Rj, so it is 1 minus Rj in the denominator. Okay, so same thing is happening. Now what's the further step? Okay, we are taking the delta R0 as the equation here, and we bring this delta Rj on the right hand side as we did in the above part. So by bringing it over there, we got the equation as in the form of like this, and we name it as equation 2. And you know it's the same, equation 1 and equation 2, they are both for different equations for the same delta R0 and delta R0, and or is for this delta Rj, that is this delta Rj can be written in the form of like this. So obviously when delta Rj is here in the left hand side, so the delta R0 goes there, it will multiply with the 1 minus Rj over 1 minus R0. So this is the delta Rj as we did above, delta Ri. We write it. It's not necessary, it's just that in the above part it was necessary, as you have to show that what is the effect on delta Ri. So it was necessary here, but it's not necessary, it's up to you if you want to write or not, otherwise it's okay. So now again the next thing, you remember that what we did, we compare both the delta R0s. How we compare the equation 1 and equation 2? You know that why we are keeping the name of these equations, so that we don't forget about them and we don't miss about them, that this is equation 1 and this is equation 2. We have to compare, our focus should be to compare equation 1 and equation 2. So we compared them. Here it is this thing, and the other is, here it is this thing, and the other is this thing here. So as we did in the series 1 minus R0 and 1 minus R0, they both cancel out. Okay, let's just do it really fast so that the time didn't so much high. So this thing comes in numerator and denominator, and the same as this. And now what we are gonna do, it stops here. Now you remember that we suppose two costs, Ci and Cj. And what is Ci and Cj? You can see there here. Okay, Ci and Cj are unit reliability costs. Oh, sorry for this unit thing. I'm telling you, you can hear from my voice, because I know that it's not easy to read it, that what it looks like. Well, the Ci and Cj are unit reliability cost. So I told you before that this Ci and Cj are basically, they can be cost in money or power or energy, they can be anything. Okay, then further, so we multiply and divide it by both the sides. So we multiply here Ci and C over Ci, Cj and over Cj. We multiply and divide it. So what we got now? The Ci delta Ri remains here, and this is the equals to part. After equals to, we bring it remains the same as it was, as the place that it was, and this thing comes here, as you see, Ci 1 minus Ri. So what was our next goal? You remember, we keep the look-wise same items, same components together, and the different looking atoms we put them aside. So here, what are the same looking items? It is 1 minus Ri and 1 minus Rj. Ri, 1 minus Ri, 1 minus Rj. We keep them together in the form of like this: 1 minus Ri over 1 minus Rj, and Ci and Cj comes here, and rest it remains Cj and delta Rj. So this thing comes out, it's separated, and this whole thing comes here. So this is basically Ci and delta Ri and Cj and delta Rj. They both are here separated, and the same looking wise things comes here. So what it gets now, what we get, that this can be greater or smaller than 1, as we talked about this before, that this thing can be smaller or greater than 1. What is the purpose of imagining it as assuming it as smaller or greater than 1? It is because that we have to select the component that we have to work on, that we have to provide our money, we spend our money to make the reliability good. We have to spend on what component to make it much better, to make the life of the component much greater. So that's why we are deciding that. So as we talked before, it is this thing. If this thing is lower than 1, so we have to select Ci and delta Ri. So we'll select this component, and if this thing is greater than 1, then we have to select this component. So this is our after all conclusion. You got it now, that this our whole theory depends on this thing, that either it is greater than 1 or either it is lower than 1. So this thing will provide us the answer to the thing, that on which item, on which component we have to spend more. As in the series also, we find out that I think if you remember, we did it like this, and we say that if in the series it was like this, because you see this likewise items, they look like the same items, they comes in separate, and the look-wise same items, they comes in separate. So Ci delta Ri, Cj delta Rj. So it is proved that we have to spend on what thing. So we took this thing. This thing is here to tell us that either we have to spend on this or this. So as I have written here, how much I have to spend to get starting reliability value. Okay, so if either greater 1, so we have to select the j components, the thing that is with the j, and either if it is lower than 1, so we have to select the I component. If it's lower, so it is necessary to go with this thing, the I1. But if it is greater than 1, so we have to go with this part. Okay, that's all for now. The parallel thing is completed, and I have explained the reliability enhancement in series and parallel both. So it's all for now.